So this is the Zeiss Icon, which we're going to repair today. And on the front here, there's a retaining screw to stop the focusing from coming all the way out. You unwind the lens and then you can access the copal shutter mechanism with that one there. I tend to place everything in order within reason as you're unscrewing them. It's quite an interesting camera. Apparently when they produced it there were 16 different variations of lenses and shutter units, which is quite impressive for one model of camera. There's the screw on the side there. It's sort of like a half moon screw, so one side engages it and then you spin it around and then it allows the outer ring, which is being moved now, to rotate, and then that's the retaining screw on the outer side there. It's easier just to nudge it carefully with a pair of tweezers like that. You can get a specialised lens tool and go around it, but I always find it a bit of a faff. If it's loose enough to do it with a pair of tweezers, it's a lot easier. And then off comes the front plate. Underneath that nameplate there's a whole load of slots in a separate plate which allows the escapement mechanism to be adjusted depending on which position it's in. You'll see that a bit later on in the video. So we're just cocking and firing it now to see what happens. The particular issue with this lens is the fact it's got oil on the blades. And when it gets oil on the blades, oddly enough it doesn't make it go quicker, it makes it go slower. Some people say it's because of the gauge block effect. When you get oil and moisture between the blades, you get a surface tension in the oil, and the oil sticks the blades together, and there isn't much power in the mechanism to allow the blades to move anyway, so any moisture content or oil or fungus which can grow between them, even though it's microscopic, it seizes the shutter blades up. So there's a second lens element in this one, which is mildly unusual. Then obviously you just lay them out in order and put the lenses down the correct way. There we go. It'll be fine. Coffee, of course, is compulsory in these situations. There we go. Yeah, it should close by itself. In this situation, it will normally trigger the shutter, then trigger the escapement on a 1 second, because nothing's being set on the escapement, so it's going full cock. So you'll get a full 1 second, or you should get a full 1 second when you fire the shutter. This is alcohol. It's partly just a small quantity just to see how much oil and stuff we're dealing with. And that's the large pot of alcohol. There we go. It's pure isopropanol. You can purchase it at most pharmacists and that kind of thing. What the alcohol does is it gets in with the oil, thins it down, and then allows you to remove it. I'm taking out the self-timer. Sorry, not the self-timer. I'm taking out the shutter escapement here. This controls most of the shutter speeds. The self-timer is the lower portion of the copal shutter unit. The reason for this is sometimes if the shutter escapement gets jammed up because the oil starts to solidify, it will jam the unit up. So it's nice to know if you've actually fixed the shutter or whether it was a fluke and the escapement movement has started to free up by itself. So by removing that, you take away an extra point that could go wrong. At least then you know exactly what you're going to be fixing. And another couple of tests. It's still being a bit sluggish. You're getting about half a second shutter, and it's not reliable. So it's clearly still sticking. At least now we know it's not to do with the shutter unit. Bit more. Usually this part of the process takes about half an hour to an hour. What I'm doing now is just blowing air on it. This makes sure that there are no more pieces of alcohol on the shutter blades, and then we actuate it a few times. It's got a lot quicker now, as you can see. The pot to the right hand side, which I'll be applying, is graphite powder, and this is a dry lubricant, which is actually what you should be using on your shutter units if you're having doing repairs. It's a common misconception, as I said earlier, to put oil on the blades. You don't really want to be putting oil on it because of the whole gauge block effect. This stops moisture build-up, but it also keeps a small layer of almost like ball bearings between the shutter blades, which allows the air to go through. And the reason for the air going through is that it doesn't stick. And then the ball bearings obviously help it along. So not only will it go faster, it will go a lot faster. Sometimes even exceeding the specification of the camera, so you need to be a little bit careful, as there's no real slowdown that I'm aware of. When removing the shutter escapement mechanism, you can then fire the shutter off, and then just as it's fired off, you can hold the lever, the shutter lever, down about halfway, and it opens up all the shutter blinds, which is really useful for what I'm doing now, is clean the rear element. It saves taking out the rear element, running it through an ultrasonic cleaner, reassembling it. Although it doesn't sound much of a problem, it can be quite an issue getting through the rear of the camera, especially on these folders, without damaging it. Once the timer unit, the retarder mechanism, is back installed, you can start by lubricating things like the self-timer here, and then more importantly the escapement wheel, which is very high RPM when it's being released. It's very similar to a lever escapement inside a watch. So the ring that is being put on now is a self-timing ring, and it controls the shutter speeds. And then as you rotate it, the arm steps up on the steps that are engraved and cut into the ring. And then the nameplate goes on the top. is the retainer ring. Can be a bit fiddly to get the pressure right on these. If you do them up too tight, it's very difficult to change shutter speed. And if you don't do them up tight enough, the pin in the retarding mechanism jumps out of the grooves and causes erratic speeds. It's also another problem which you find on early cameras is the erratic speeds. Usually it's just a case of the retaining ring or the copal shutters come a little bit loose. You can tell if they've never been touched before, usually by the fact that the original manufacturer puts a drop of candle wax on that retaining screw, on the half moon screw, to stop it from rotating around and then obviously coming undone. If you didn't have that, when you rotate the shutter speeds, it would loosen the ring off and then that would all come apart very, very quickly. You always mark the start position on any of these lenses, so that when you screw them back in, they go to the right place. And there we are. A Zeiss Icon.